Alright, looking at question 1.1.1, we have to solve for x. And 1.1.1, we are solving the quadratic equation x squared plus x minus 12 is equals to 0. Our equation is already in standard form. The form ax squared plus bx plus c is equals to 0. So the first step will be to factorize. Equals to 0, we'll have x plus 4x minus 3. And if you still struggle with factorization, especially factorizing of a quadratic equation at this point, to solve any quadratic equation, make use of the general quadratic formula, of which we are going to apply in question 1.1.2. Then from here, equate each factor to 0, x plus 4 equals to 0, or x minus 3 equals to 0, and solve for x. X will be equals to negative 4, or x will be equals to 3. Then coming to question 1.1.2. We have the quadratic equation 3x squared minus 2x is equals to 6. And here inside the brackets, we are told that answers must be correct to 2 decimal places. This tells us that we need to make use of the general quadratic formula to solve for this quadratic equation, as we will not be able to find the factors. So first step, let's put the equation in standard form. Three x squared minus 2x transpose 6 minus 6 is equals to 0. Then we are now going to apply the formula x is equals to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So on our equation, we need to identify the parameters a, b, and c. A is the coefficient of x squared. A is the coefficient of x squared, so a will be equals to 3. B is the coefficient of x. B is equals to negative 2. And c is the constant number. C will be equals to negative 6. Then we go and substitute those values in our equation. X will be equals to minus into b, negative 2, plus or minus the square root of b, negative 2 all squared, minus 4 times a is 3, multiplied by c is negative 6. And all this is divided by 2 multiplied by a. Our a is 3. Equals to negative times negative 2, positive 2, plus or minus. Then inside, to now compute the square root of minus 2x squared minus 4 times 3 times negative 6, make use of the calculator, and you should get 2 the square root of 19. 2 the square root of 19 all divided by 2 times 3 is 6. Then x will be 2 plus 2 the square root of 19 all divided by 6, or x will be equals to 2 minus 2 the square root of 19 all divided by 6. Therefore, x will be equals to 1,79. Use your calculator, or x will be equals to minus 1 comma 1 2. Now 1.1.3 and 1.1.4, we are still solving for x. We are still on question 1.1 where we solve for x. Now 1.1.3, we have our said equation, or equation with the radical. The square root of 2x plus 1 is equals to x minus 1. And the part of the equation that is having the square root sign, it is isolated on the left hand side. So in this case, the first step will be to square both sides. We take the left hand side, 2x plus 1, and then we square it. It will be equals to x minus 1, and we square. Then on the left hand side, the square cancels the square root, then we are left with 2x plus 1 will be equals to, on the right hand side, x minus 1 all squared. We'll have x times x squared, then x multiplied by minus 1 minus x twice minus x minus 2x, and then negative 1 times negative 1 positive 1. Then from here, let's put the equation in standard form. Let's transpose minus x squared plus 2x minus 1. On the left hand side, we still have 2x plus 1. This will be equals to 0. Then adding the like terms, minus x squared, 2x plus 2x, 4x minus 1 plus 1, 0. This will be equals to 0. Then let us divide or multiply throughout by minus 1, so that we simplify our equation to x squared minus 4x is equals to 0. Then our quadratic equation, x squared minus 4x, take out the common factor of x, then we'll be left with x minus 4 inside the brackets equals to 0. Then equate each factor to 0, x will be equals to 0, or x minus 4 will be equals to 0. Therefore, x will be equals to 4. Now, with the said equations, or equations with radicals, where we had to square both sides, before, when you get to this step of solving for x, you need to check your solutions. You need to check your solutions to check if both the values of x are the solutions. How do you do that? We first take the left hand side, we substitute. Let's start first with, you can do this checking aside, and then from there what you need to show is your conclusion. But I will show you how do you check here. Let's check x is equals to 0. Left hand side is equals to, we are going to substitute 0 on the left hand side of our equation, the original equation, the square root of 2 times 0 plus 1. It will be equals to 1. Then the right hand side will be equals to 0 minus 1, which is equals to minus 1. Left hand side is equals to 1, right hand side is equals to minus 1. Therefore, it's clear that the left hand side is not equals to the right hand side. Therefore, x is not equals to 0. X cannot be equals to 0, because when we substitute 0, left hand side is not equals to the right hand side. Now let's check the other solution. X is equals to 4. Now let's substitute on the left hand side. The square root of 2 times 4 plus 1 will be equals to square root of 9, 3. Then let's check the right hand side. We substitute right hand side. 4 minus 1 will be equals to 3. Left hand side is 3, right hand side is 3. Therefore, left hand side is equals to the right hand side. Therefore, this means x is equals to 4. So the only solution is not x is equals to 4. So the only solution is x is equals to 4. So that is how you check. So now that we have checked, let's just erase all this. We can conclude by saying, therefore, x is not equals to 0, x is equals to 4. Meaning x is equals to 4 will be the only solution. Alright, now on question 1.1.4, we have the quadratic inequality x squared minus 3 is greater than 2x. So first step, let us write our inequality in standard form. X squared minus 2x minus 3 greater than 0. Now we need to determine the critical values. Finding the critical values, we are just going to change the inequality to equality and then solve for x, so that we can get the x-intercept, as we are going to make use of the graphical notation to solve for x. So critical values, x squared minus 2x minus 3 equals to 0, and now we solve for x. Then we have x minus 3 multiplied by x plus 1 equals to 0. Then we have x minus 3 equals to 0, or x plus 1 equals to 0, x is equals to 3, or x is equals to -1. These are our critical values, or rather the x-intercepts, as we are going to make use of the graphical notation. So let's draw the graph. We have the x-axis, the first x-intercept -1, the other x-intercept 3, and then we draw our parabola, our quadratic function that is having the minimum turning point. It will always be having the minimum turning point because we always ensure that before finding the critical values, the coefficient of x squared is positive. A is positive, therefore the graph will have a minimum turning point, or it will be a smile. Now, before finding the critical values, how is our inequality? Greater than 0. In this context, greater than 0 meaning above the x-axis. So let us shade the part of the graph that is above the x-axis. Above the x-axis. Now the question is, -1 and 3, are they part of the solution? No, because the inequality is just greater than, not greater or equals to. Therefore, how do we show that on the graph? We show that by using open circles. -1 and 3 are not part of the solution. So now we are ready to write the solution. Where is our solution? Where we have shaded red. that is where we get the solution. So looking at -1, where have we shaded red on the graph? On the left of -1. So it will be where x is less than -1. Or then looking at 3, where have we shaded on the graph? Above the x-axis. Therefore, this is where x is greater than 3. It is to the right of 3 along the x-axis. Therefore, this is where x is greater than 3. And then this will be our solution for 1.1.4.